Welcome to Algebra 1, Lesson 8 with Miss Barrett. So today we're going to do a factoring review. So far, we've learned how to factor when we can factor out a GCF, when it's a trinomial or a quadratic, where the A term or the coefficient, the leading coefficient is 1, and also when it's a trinomial or a quadratic where A or the coefficient term is not equal to 1. So here you see we have all of those methods. Now, an example of when you can factor out the GCF is here. AY to the fourth minus 4y minus 24y cubed. How do you solve this, or how do you factor this, is by first finding the GCF of the numbers and the variables using factoring trees. When you take out the GCF, you put it in front of the parentheses, and you divide everything that's left by that GCF to see what's left. You put what's left in parentheses. Okay. And when do you solve using the GCF method? When you solve it when all of the terms have a common factor. Okay. Now, when you have a quadratic or a trinomial where a is equal to 1, an example of that is x squared minus 6x plus 9. Here, clearly you can see that a is 1, b is negative 6, and c is 9. In this case, you find the factors of c, so you would find the factors of 9 that add to make b. So you find the factors of 9 that add to make negative 6. Once you find those factors, your second step is to write the numbers out as factors x plus or minus, depending on the sign of the factor, parentheses, x plus or minus the other factor. Now, when do you use this method? You use this method when, after you have factored out a GCF, if possible. So there's a possibility that you would have a problem like this where you had to first factor out a GCF and then you got this trinomial. In which case, after you factor out a GCF, if your A value is 1, then you use this method. Next up, if you have a trinomial where the A term is not equal to 1, here, as you can see, you have 6x squared plus 19x plus 10. I cannot factor a GCF here. These three terms do not share a common number or variable. Therefore, I must find the factors of A times C, so 6 times 10, that add to make B, which is 19. Once I find those factors that add to make B, I'm going to split B into those two factors, which will give me 4 terms. Once I have my 4 terms, I split them into groups of 2. So it's going to be 2 sets of parentheses. That's why they call this the grouping method. Once I have my 2 groups, I factor out the GCF of both of the groups and find what's left. My factors will be written as the GCF, first GCF, plus or minus the second GCF, and then the other factor. We use this method when you have factored out a GCF, if possible, and still the A term is not equal to 1. Let's look at some examples. Now remember, this is very important. The GCF can be used for all other methods. So the GCF methods can be used for the trinomial when A is equal to 1 and the trinomial when A is not equal to 1. And I will give you an example of that later on. Now, the GCF method. Here we have 8y to the fourth minus 4y minus 24y to the third. Now we need to say, okay, do any of the numbers, do all three of the numbers have a greatest common factor or a largest common factor? Now, 8 has factors of 1 and 8, 4 and 2. 4 has factors of 1 and 4, 2 and 2. And 24 has factors of 1 and 24. We can do 3 and 8, 4 and 2, and 2 and 2. As we can see, the greatest common factor, the largest number they have in common, is 4. So I can say that 4 is a GCF. Now, I have to look at the variables. We have y to the fourth, y, and y to the third. Again, y to the fourth, y, and y to the third. As you can see here, each of those terms has at least one y. So 4y is going to be my GCF. I put my GCF outside of the parentheses. Divide everything inside what's left by 4y, by the GCF. And this is going to give me 8y to the fourth divided by 4y, which is going to give me 2y to the third. Because remember, y to the fourth divided by y to the first is like saying 4 minus 1, which is 3. Now I have negative 4y divided by 4y, which is going to give me negative 1. And then 24y cubed divided by 4y is going to give me negative 6y squared, because negative 24 divided by 4 is negative 6. And y cubed divided by y to the first is like saying 3 minus 1, which is 2. Okay. Now, if you want to, you can look at this inside parentheses and say, well, that's not written in standard form. Okay. This answer is correct, but you can also write it as 4y times 2y to the third minus 6y squared minus 1. That's standard form. It shows this polynomial from highest exponent to lowest exponent. And this would be your answer. That is the GCF method. Next up would be when a trinomial or a quadratic here, this is a quadratic because the highest exponent is 2. When a quadratic, the a term equals 1. Here, a is 1, b is negative 6, and c is positive 9. I do advise that each time you do a problem like this, you identify your a, b, and c, because it will help you decide which method to use. Here, clearly a is 1, so I need to find my factors of c, which is 9, that add to make negative 6. So over on here, I'm going to find my factors of 9. 1 and 9, 3 and 3. It could also be negative 1 and negative 9, and negative 3 and negative 3. Again, because 9 is positive, if I multiply a positive 1 times a positive 9, I get 9. But if I also multiply a negative 1 times a negative 9, I get 9 as well. Well, which two of these factors add up to make negative 6? That would be negative 3 and negative 3. Now I'm going to do that last step by writing out my factors as x minus 3, and x minus 3. And that would be my answer. Now remember, you can check these answers, these factors, by doing your multiplication. X minus 3 times x minus 3. Do your FOILs. First is x squared. Outer is negative 3x. Inner is negative 3x. And last is negative 3 times negative 3, which is positive 9. Combine your like terms. You get x squared minus 6x plus 9, which is exactly what you started off with. Last but not least, when you have a quadratic trinomial where a is not equal to 1, you have to use the grouping method. This is the last method we learned about last week. As you can see here, I cannot find a greatest common factor. Okay, your first step in any of these types of problems is to try to see if you can find a greatest common factor. If you cannot, then you just move on to this step. Okay, so grouping. Grouping says you have to first find the factors of a times c that add to make b. So a times c is 6 times 10, which equals 60. So I have to find the factors of 60 that add to make 19. Let's write out the factors of 60. 1 and 60, 2 and 30, 3 and 20, 5 and 12, 6 and 10. What else? 4 and 15. And I believe the list goes on. Use your calculator if you need to. But for sake of time, I'm not going to keep on going. We can also say negative 1 and negative 60, negative 2 and negative 30, negative 3 and negative 20, negative 5 and negative 12, and negative 6, negative 10, and negative 4 and negative 15. But as you can see, this 19 is positive. So our factors of 60 that add to make 19 are 4 and 15. So now I need to split this 19x into two factors. So I'm going to rewrite what I didn't bother. 6x squared, okay, plus 4x plus 15x. Again, I broke down that 19x into those two, plus 10. Now, as you can see, I have a 4-term polynomial. So I'm going to break them into two groups. Six x squared plus 4x is group 1. And my second group is going to be positive 15x plus 10. Now we're starting our grouping method. Once you have your two groups, you have to find the GCF of both of those. Okay. So what's the greatest common factor between 6 and 4? That would be 2. And the greatest common variable would be x. They both have at least one x. So when I divide both of these by 2x, I get 3x and then 2. Because 4x divided by 2x is 2. I must do the same with 15x plus 10. Now, if you need extra space to find your greatest common factors between 15 and 10, that's okay. Three and 5, we have, or you can say 1 and 15, 3 and 5. And then here you have 1 and 10, 2 and 5. So clearly the greatest common factor is 5. So it becomes positive 5. They do not share a variable in common. So it's just 5. Divide both of them by 5. You get 15x divided by 5 is 3x. And then 10 divided by 5 is 2. As you can see, we accomplished our goal. We wanted these two in the parentheses to be the same, 3x plus 2. So now I'm going to take my two GCFs, and I'm going to put them together as a factor, 2x plus 5. And I'm going to take the other factor, which is 1, considered 1, 3x plus 2. And that would be my answer. So for the sake of time, again, I'm not going to do my check on here. But remember, you can do a check by doing your FOIL. Now, there will be a time where you can use the GCF method first. Let's look at that time. If I had, for example, let's say I had 2x squared minus 12x plus 18. And I said factor that trinomial. Well, you would say first that this trinomial has an a term that's not 1. And you might say, okay, I need to use the grouping method. But if you look at all the terms, they share a common factor. 2 has common factor of 1 and 2. 12 has a common factors of 1 and 12, 3 and 4, 2 and 2. 18 has a factor of 1 and 18, 3 and 6, 3 and 2. As you can see here, the largest number they have in common is 2. So 2 is going to be the GCF. Going to put that on outside of parentheses and divide everything by 2. 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x. 18 divided by 2 is positive 9. Okay. Now, as you can see now, what I have here that's left is a trinomial where the a term is equal to 1. It's the same trinomial we solved on the other, or we factored on the other paper. So I would now use those same steps when the a term is equal to 1 to factor this out. And when I do that, I would get the answers 2 times x minus 3 times x minus 3. And if I do my FOILs, I would get the same answer that I started with in the beginning. Okay. So there is a situation where sometimes if you can take out a GCF, well, all the time actually, if you could take out a GCF, you need to take out the GCF first. And then look to see what the next steps are to factor out the problem. For your individual work, your individual practice, you will be factoring these 4 problems using whichever skill or whichever method makes sense. So first you need to identify what kind of factoring problem it is. by looking at the chart we just went over and looking to see what are the characteristics and what method will work the best. Once you identify the method or the strategy, use it using the skills that you learned over the past couple of weeks. This last one, this number 4, is tricky. Take your time and do your best. We will go over it next lesson. This individual practice is due by Wednesday, April 8th. Have a wonderful day. Take your time and do your best. Bye.